In this video, we're going to go over the basic system that's made by Advanced Treatment Technologies, and we make this in 3 different models. This video is designed to cover all 3 of these versions. So what we'll do is we will cover in detail the version that we use most frequently, and then we will cover at the end of this video the couple of variations that exist between the skids. So again, this video is designed to be used for operation setup, troubleshooting, installation, all that kind of stuff. So with that said, we recommend that you watch this video in its entirety, maybe a couple times if need be, before beginning to hook up to the system and operate the system. This will be the version that we'll be showing you today. The versions that exist all have the same components with the exception of the filtration. So this particular unit has a bag filter, stainless steel bag filter, where you have to change out the bag once in a while. This version over here has an auto backwashing filter that you really don't have to do anything with. And then we make a third version that has neither one of these filters and just has a regular carbon cartridge filter. We'll cover the operation, function, all that stuff of this system, and then at the end, we'll come back and explain the stuff that's pertinent to the backwashing filter and the carbon filter. The first thing we're going to go over is the installation of the system. So this is everything that needs to be done before you begin trying to turn this thing on and run water through it. So the first thing we're going to do is hook up the power. We're just going to open up the control panel. And then you'll see right here is where we need to make the connection. There should be a hole right here for you to run your power through. And then we're going to connect directly as seen here with our 2 hots and our neutral. And then we're going to hook our ground up. Really, you can do it anywhere. We recommend kind of doing it right here on this screw. So again, this is single phase 208 with a neutral. That's the power that's needed to connect. That'll all be right here as shown. The other thing that we have the option of connecting to in here, if you would like, is this little guy right here. This is a little relay, and this will also be shown on the electrical drawings, but this is an optional relay that you can use for a shutoff switch. So for example, let's just say that you had an ozone leak from the system. That's not very common. You can run a wire from this switch, say to a hallway or somewhere else that's not inside that room, so that you can have a kill switch. You could shut the system off without having to go in. And if you do that, again, this is in the electrical drawings, but you'll see A1 and A2 for this relay. A1 is your line or your hot leg, and then A2 would be your neutral. If you are going to use this relay, it goes without saying, you shouldn't have power run to your system yet, but just in case you need to know, you can flip this little switch up right here, and this also acts like an e-stop for this. You probably shouldn't have to mess with that, but at least make sure that that is flipped down before we try to run the system. Now, one final thing about the power hookup to this, all of the components on the skid needing to be powered are powered right here from the control panel. So when you wire into the control panel, all this other stuff is taken care of. The only exception to that would be if you have this filter model. This filter has to be plugged in separately, and it's just single phase 120. It requires like 2 amps. This is the power supply for that, and so there'll be a cord hanging off right here somewhere, and you just plug that into a standard outlet. Next, we're going to take just a minute and we're going to talk about the different components on the system just briefly, tell you what they do, and we're going to trace the flow of water as well as the flow of gas through the system and show you how all this sort of integrates together. We've already made all the connections here, but we have our inlet connection right here, and then we have water coming out. Now, you can't see this, I guess, because we already have this hooked up. These are female connections. We've intended for you to have to thread this male adapter in there. And the reason for that is if you are plumbing and you make some mistake and there's a leak or whatever, we don't want to run into a situation where you have to cut into the plumbing that we've pre-built here. So in other words, if you had a leak, you would just take this male adapter off and start over again. But water's going to come in here. You'll see that we have a bypass. This is if you need to do system maintenance or you need to have the system shut off, but you still need water for whatever reason. You would close this, and you would open your bypass, so it would be reverse of what you see here. More about that later. But you're going to see that water is going to come in here, and the first thing we're going to pass through is this flow switch, and this flow switch is what's going to turn your system on and off. And when your flow system, when your system is on, in other words, your flow switch is activated, you'll see this green light come on right here. And again, we'll see that later. So when water moves through your flow switch, it turns your system on. Water is going to flow then into the top of this contact tank. This is a mixing tank. And as we're going to see here in just a minute, we're going to be mixing ozonated water, water that's already been treated, with the incoming water. This is a vent valve. You rarely have to do anything with this. but this is venting off the excess ozone. So once the water is maximally dissolved with ozone, the excess has to be vented off somewhere, and that's what this is going to do. So again, we're going to move through our contact tank. You'll notice that we come in the top of the contact tank, out the bottom. And when we come out the bottom, we can do one of two things. We can either trace that pipe back over here to this pump, or we'll go around the back into the bottom of our filter, which we'll see here in just a second. Water coming over here to the pump goes through this assembly. We call this our injector manifold or our injector assembly. This is where, as we'll see in a second, this is where the ozone is mixing with the water. But to go ahead and finish this flow, we're going through the pump, and if we trace this pipe down around, you'll see that it goes in the back of that gray contact tank. So again, completing a loop. We have a constantly recirculating loop between the treatment, which is occurring here, and between the contact tank. Now, like we said, we either go to the injector for ozonation, or we go to the right here and we follow that pipe around the back and it goes into the bottom of this filter. So again, out of the contact tank, we either go for retreatment or we go back to the filter, which then the water will come out of the filter and go to use. So we come out of the bottom of the filter, we come up past this gauge, and then to our outlet. And so that is the water flow all the way through the system. Now with the gas flow, we're beginning here with the oxygen concentrator. So it's concentrating ambient air down to mostly pure oxygen, nearly pure oxygen. That O2 is going to feed an ozone generator. So we're making O3 from O2. And then out of the ozone generator, we have this little manifold back here that's going to be important later. For now, we'll skip most of it, but you're going to follow the tubing out of the ozone generator. We're going to go through this little valve here, and we'll talk more about that later. And then we're going to follow that tube ultimately down into this needle valve and then into the injector. So again, we traced our water flow this way, and now we've traced our gas flow from the concentrator through the generator, through this little valve, and then down into the injector. Next thing we're going to show you how to do is install the bag filter. It's very simple. We're going to loosen this. We're going to open the collar. We're just going to pull off the top. We're going to take our bag. We'll send some of these with your system, by the way. And if you look down in here, we're going to have to loosen this little thing that you turn in the middle. There's a little clip on each side that this fits under. You'll see this here in just a minute, but these ends fit under that clip, so you just loosen this up, take this out, and then what we're going to do is take our bag and just stuff it down in there. Try to get it down in there as far as you can, but really the water is going to push it down, so just do the best you can. And you'll see that there's a lip that it fits against. So all you have to do is just push it right down in there. It's very intuitive how it fits. So after your bag is installed, then we're going to take this, put it back in there, and you'll see the little clips right there. We're just going to make sure that this bar is under each clip. There we go. And then after it is, we're just going to tighten it back down. Just like that, and you'll see it kind of locks into place there. Okay, hand tight is fine. When you get done, make sure the O-ring is seated good. We're going to put this back on and then reinstall the collar. All right, next we're going to show you how to install the ORP probe. Now the ORP probe is going to be critical in the system determining how much ozone is being produced. And so that is going to come zip tied maybe to this corner or maybe right here. It'll be somewhere right in there. It'll look yellow like this. It'll have a little plastic cap that goes over the end as well. I would hang on to that, but you'll thread tape it. And then what I would do is I would actually twist it backwards so that when you twist that in there, the cord will sort of unwind itself and it'll be relatively straight. Now, one quick thing about the ORP probe, this does not need to be out of the water for very long, so no more than a couple hours. It dries the tip out and then it messes the probe up. So I'm going to go ahead and show you this because we're getting ready to fill the system with water. If you think it's going to be a little while before you're actually going to run water into the system, then I would not do this just yet. one of the final parts of installation here, there are several points on the system that ideally need to be run to some kind of drain. Now, I'll tell you which ones, are recommended and which ones you can kind of get away with not piping to a drain, because we realize that in certain situations that may be difficult, but we'll go through that here. So we have this point, and then this point over here by this valve. All three of these are recommended to run to a drain. Doesn't have to, but needs, ideally would. So let's go over each one of these really quick, and I'm going to show you how to connect. Now, for these 3 points of connection, we're going to send you a roll of ozone-proof tubing with every system. If this winds up not being enough for some reason, just let us know. We can get you some more. But normally, it's about 25 feet. That's normally going to be plenty. So the first thing that we need to plumb, ideally to a drain, is the vent valve. Now, remember, we talked about already that the vent valve is venting off the excess ozone that can't be dissolved in water anymore after the water is saturated. It's important to note 2 things about this. One, out of this connection are going to be coming ozone and water. It's more ozone than it is water, but it will leak out water once in a while, and that's normal. If you do not want to plumb this to a drain, it's okay. But again, the reason we recommend it is twofold. One, you'll slowly just kind of drip water down on the skid, which is not going to hurt the plastic, but in time you could have somewhat of a mess in there. And the other thing is, if you don't vent this off, you will smell a little bit of ozone in the room. Now, just because you can smell a little bit doesn't mean that's going to hurt you. If you're not coughing, basically you're fine. But the ideal situation is we would like to have that vented somewhere. So a lot of people will vent this outside. You can do that as well, but keep in mind that, again, water is going to be coming out this tube as well. So if you live somewhere where it's going to be freezing at night, we cannot have this line froze. So again, all things considered, it's best just to run this to a drain. Ozone is actually heavier than air anyway, so if you pipe it down into a drain, it's not going to waft up into the air. It's going to stay down there, and it's going to slowly convert to oxygen. It's not going to cause any problems. So let me show you how to do one of these really quick. You're going to take off the collar for this fitting, and there are going to be these little things called ferrules inside, which I'm going to show you. If these are not in there, then you cannot make this connection, so make sure that these are in there. You're going to hold your finger over the tube, push your finger through, and your connections should already be there. The big one goes closest to the fitting. The little smaller one you'll see kind of telescopes down inside that one. And then your collar goes over. Because we're going to take that, we're going to stick that in the fitting. We need to make sure that that tube goes all the way down in there. If you don't, then what's going to happen is it's going to crimp these ferrules right on the edge, and we won't make a good seal. So make sure that our tube is pushed all the way in, and then let's go ahead while it's pushed in and let's turn the collar. At that point, we are going to hold the fitting while we crimp it. And these will require a 9/16 wrench. So we're going to hold it still, and we're going to crimp it down on there. There we go. And what I always like to do is to undo it and take a look at your work and make sure that you got it right. And what you'll see, if you did it right, is you'll see the smaller piece pushed inside the larger piece, and you'll notice how the tube narrows just a little bit right there, and that's because it's been crimped around it. That means we're going to form a good seal. And then we should always see some of the tube sticking out past the ferrules. So that would be how we crimp the tube in for the vent valve. Now, for the filter, it's going to be the exact same thing. When we're filling this filter, it will trap air just like the contact tank will. But unlike the contact tank, there's no vent over here like we have here. So we've made a little manual vent. But when you're filling, and we'll show you this in a little bit, but you're going to be opening this, and this will spray some water. Now it's not going to come out in a steady stream, but until it gets full, it's just going to spray. It might be a little messy. So again, this is optional, but we recommend that you pipe this into the drain as well, and you'll crimp this the exact same way. Finally, over here, you'll notice that there's one more compression fitting. All of these are the same size. They all require a 9/16 wrench. This is a bleed-off valve for the system. So, like we talked about earlier with our injector, if water should ever leave the injector back up through this tubing and start to get close to our generator, we want to have a way to keep that from happening. So this would actually vent that water off. So ideally, water will never come out of this. If everything goes perfect and you service the system the way you're supposed to, you'll never actually need this. And like I said, worst case scenario is the water's just going to fall down. So again, this is optional to vent this off, but not mandatory. And if you do that, you'll install that tube the exact same way in this fitting that we did for the contact tank. Now, at this point, you can do one of several things here. We recommend that these 3 tubes not be connected into a common fitting, because that could potentially allow water to back up over here towards our generator. And that's the whole point of this apparatus over here. So we don't want to do that. So what I would do, make your 3 separate connections, and then all 3 of those connections go to a drain separately. Now, if you're tubing, if you don't have enough or just you don't want to for whatever reason, one thing you can do, you can run all 3 of these tubes into, say, like a 1-inch pipe, and they don't even have to be sealed off. If they're just run down in there, you know, water will run on down to your drain. So that's an option too. But however you do it, we recommend that these 3 not be connected. Last connection to a drain that you would want to know about are these guys down here. We have a drain for the contact tank. Really, you should never need this, but let's just say for some reason you wanted to move the system, it'd be nice to get all that water out. So you can drain your contact tank here. And then this is a drain for the filter. Now, this drain for the filter you will need occasionally, because when you change out your bag filter, you're going to need to close all the valves coming into your system. You're going to need to let some water out to depressurize the system, but you're also going to need to let enough water out so the level comes down in here so that you can work without making a big mess and get your bag in and whatnot. So this one, again, does not have to be piped to a drain if you don't want to, but occasionally you would just have to let some water out on the floor, and it's probably going to be about, 3 to 5 gallons, something like that. These could even be just dry fitted. They're not going to be under pressure if you ever need them. And these are connections that you might also want to pipe to a drain. The last thing we're going to go over here before we actually start the system up is what positions that all of the valves should be in. Now, most of you will be able to figure this out. It's somewhat intuitive, but let's just go through that anyway. Like we talked about our bypass here, we're going to keep our bypass valve closed. And for now, we're going to keep our inlet and our outlet valves closed. Obviously, they will have to be open when the system is running, but for now, we're going to leave those closed. We're going to go ahead and make sure that the outlet, which is on the bottom here, the outlet of our filter, we want to make sure that's open. The suction to our pump is open, that the 2 valves on either side of our injector are open, that the inlet right here to our filter is open, that the vent is closed. We're going to make sure that our 2 drains are closed. And then we're going to make sure that this one is open. This is the line coming from the injector and the pump back into the contact tank. If your valves are in these positions, the next thing that we're ready to do is actually put water in the system. So in this next section, we're going to talk about actually starting the system up, having it run, and then the points of understanding that you need to have to operate the system appropriately. So first thing we're going to do, this is assuming that you've got your power on and that your ORP probe, like we talked about, is hooked in. We're going to come over here to the side and turn our power on right here. You'll see that the light comes on telling you that it does have power, the standby light. So now we're actually going to run water through the system. The very last thing you need to know before we put water in here is this system is designed to operate between 30 and 50 psi incoming pressure. Whatever your supply is into here, if it's from a holding tank or if it's from your well or if it's municipal, whatever it is, it needs to be 30 to 50 psi. If you do not operate the system between 30 and 50 psi, you're most likely going to have problems. One, if the pressure is being too high, you can mess up things. And if the pressure is too low, it'll actually mess with our ability to get ozone into solution. So you need to be between 30 and 50. If you have no way, I don't know what the reason would be, but if you have no way to get your pressure up to 30, contact us and we might be able to do some things to help you work around that. But really, this needs to be between 30 and 50. For the purposes after this, I'm just going to say 40 psi, but just know it's between 30 and 50. Having said that, if you need to raise your pressure to get there, raise it. You can also buy a really cheap pressure regulator or reducing valve from Lowe's and stick that on there. But don't ignore this. It needs to be between 30 and 50 psi. So when we run water through the system, we can do that in 2 different ways. We have a manual mode and an auto mode for the system, automatic. If the system is in manual mode, you turn it on and it's going to run until you turn it off and take it out of manual mode. And then if you have it in auto mode to the right, it's going to turn itself on and off depending on water use. And the way that works is this. When water begins to flow through the flow switch, and it does that because you're using water, right? So as water exits the system, new water comes into the system. The flow switch recognizes that, and it turns the system on. You'll see this green light turn on when we actually turn the system on here in just a minute. That means your flow switch is active and your system should be on. So again, we have to be in auto mode for the flow switch to be doing its job. The system will turn on with the flow switch. The system will also turn off because of the flow switch. We have a built-in timer, and we can set that to different lengths. We standard set it to about 5 minutes. I would recommend that you leave that there, and we're actually not showing you how to adjust that timer because you can cause some problems. If a situation arises and you or we feel like we need to make that longer, shorter, whatever, we'll talk you through that. But for right now, I would recommend not messing with that timer. What that timer is there for is 5 minutes after you stop using water. So in other words, 5 minutes after water stops coming out of the system, this system will still run for that 5 minutes. And the reason for that is simple. What we want to do is we want to make sure that all of the incoming water that came into the system but didn't come out is fully treated and ready for use the next time that you start using water. So again, the system will normally run, and it should, for 5 minutes roughly after you stop using water. So if you see, we get calls sometimes, oh, the system's still running and I'm not using water. I say wait a few minutes, okay? 5 minutes after you stop using water. So we're ready to run water through the system. So we're going to open our outlet. Bypass still going to be closed. We're going to go ahead and open our inlet. I'm going to step over here and turn our pump on, and once that happens, should register on the flow switch. Green light should come on, and system should turn on because it's now in auto mode. So just like we said, flow switch is active. It turned the system on. So we've got water filling the system. So let's step around and look at the filter. Like we talked about already, we need to vent this filter off. You'll be able to feel air, and you can see water as well coming out of the contact tank. So again, you can see kind of what will happen if you don't run that to a drain. You'll get a little bit wet. So same thing with this filter. We just want to crack that. You'll be able to hear air coming out of it. You'll be able to feel it. It doesn't have to be very much, just a tiny bit. You can even choke this down just a little bit so that we prevent a steady stream of water coming out. And we're going to wait until this fills up. And then as soon as we see water start to come out of here, we're going to close that off because we know that the filter is full. Now that the system is running, there's an optional piece on here that you may or may not have. This is a pressure sustaining valve. If you're using this system in conjunction with a holding tank, then you will have one of these. If you have a municipal or a well line that is being plumbed directly into this and you don't have a holding tank, then you will not have a pressure sustaining valve. If you do have one of these, it will come pre-installed, and that would be right here if you have this bag filter system. There's also a little optional line off if you need to run. Some of our customers will need to run water somewhere else as well as back to a holding tank. But if your setup requires that, you'll already understand this. This will already be pre-installed with that line for you to connect to if you need to. And if you have the backwashing filter line or system, that would come installed right here. And so this line would still be available for you to tap into. But again, you would not have to install this. You just need to understand how to operate it, which is what I'm going to tell you about next. The purpose of the pressure sustaining valve is to sustain pressure, hence its name, back through the system. So in order to get ozone into solution, we need to maintain a certain pressure. Remember, that's why I also said we need to be between 30 and 50 psi on the incoming pressure. So there's that again. Now, if you do have one of these and you need to adjust it, you're just going to take off this black cap, and you'll see that you'll make the adjustment up or down with a flathead screwdriver. It's very simple. And you're going to know what the pressure is adjusted to because you'll have a gauge right here coming out of the filter before the pressure sustaining valve, and you'll have one over here as well. It'll just be in a different place, but it's on the outlet of the filter before the pressure sustaining valve, the same as this system behind me. The way that you need to think about this is you need to know that it takes about 5 psi cracking pressure to open this. If your incoming pressure is 40 psi, which is about what we recommend, if your pressure sustaining valve is also set to 40, then you're not going to be able to move water through the system because you have to add the 5 psi that it takes to open this. So another way to say that is your incoming pressure has got to be at least 5 psi greater than what this is set to move water through this. So if you keep those things in mind, you'll be able to operate this effectively. That's pretty straightforward, but if you need more help with this, you can feel free to ask us. Next, we're going to talk about adjusting the set point. The set point is the value, that's the term that we refer to, and it describes the amount of ozone that we're putting in solution. We're dependent on the ORP probe for that. So the ORP probe is reading what we call the ORP levels in the water. ORP stands for oxidation, reduction, potential. It's a measure of the residual oxidizer in the water. So after the demand of the water has been met, this measurement, this ORP measurement, is the measurement of the oxidizer that's left over. This is the potential of the water to continue to be oxidized. We'll say it that way. We have a set point for that. The higher that set point, the more oxidizer, in this case ozone, we're going to put in the water. The lower the set point, the less that we're going to put in there. The set point is going to be different for every system. On our YouTube channel, we have another series of videos, one in particular, that deals with ORP in particular. And if your process or just your curiosity requires more information about that, feel free to watch those videos. There's an expanded sort of explanation right there. But for now, I think that'll suffice what we need for. So first I want to go through how to calibrate the probe, because again, if it's not calibrated properly, it's not going to read properly. You're not going to put the right amount of ozone in there, and that could be too little or too much. So to calibrate, we're going to send you some calibration solution. It comes in a little bottle. It'll say -470 on it. Obviously with the system off, but the panel still powered on, we're going to close off this valve and this valve so that we can take the probe out without losing a whole bunch of water. Now remember, I told you earlier that the probe comes with a little plastic tip. I recommended that you save that. What you'll do is you'll take that calibration solution, you'll put it in there, take the probe out, stick it down in there. Your values here on the screen are going to fluctuate a little bit. It may take it a minute or two to stabilize, but when this reading finally stabilizes and it quits moving, we're going to hit measure, and then you're going to insert the screwdriver where it says cal right here, calibrate, and then you will turn this either up or down until this number reads 470, because remember, we're calibrating to 470. That's the millivoltage of the ORP solution. Once we're done calibrating, once you've turned this and this number says 470, then you're going to obviously take your screwdriver out, you're going to hit measure, and we're done. The probe should be calibrated, should be ready for use. The second thing that you're going to need to know how to do is adjust the set point, which we were just talking about. To know what the set point is currently, we're just going to come here and push the set button. We're set to 601 right now. If I want to change that, after hitting the set button, I'm going to insert the screwdriver where it says set, and you can see by turning it, I can adjust it down. If I turn it to the right, I can adjust it up. Once again, if you need more information about where your set point needs to be, you can reference our other videos or you can give us a call, but this is how you would make that adjustment. When you're happy with where your set point is, you'll once again push measure, and we'll go back and it'll show you what the current ORP level is. System will then begin to operate at that new set point. One other quick thing about your ORP controller. This is essentially telling you what the ORP level is in the water. In this case, you can think about it in terms of how much ozone is in the water. So our probe has to be calibrated to get a correct reading here. But then also there's this little switch right here, off, auto, or on. This thing is going to tell your generator when it needs to be on and off. We recommend that you always leave that on auto. There might be a couple situations where you would want to mess with this, but this 99% of the time you're going to want to leave this here. If you switch this to the off position, your generator's never going to turn on and make ozone. If you switch this to the on position, it's always going to stay on and it's not going to turn off when it's supposed to, and then you're going to go way over your ORP. And by leaving this in auto, we're ensuring that the generator turns on and off when it needs to. On and off here is not the same thing as being in auto or off or manual here. This controls the whole system. This controls the generator only. So leave the ORP controller switch here on auto mode, you won't have any problems. The last thing we need to talk about in terms of operating the system is adjusting the flow of the oxygen concentrator and the ozone generator. Now, when we test these systems in-house, we're normally operating around the 40 psi that we told you that you want to maintain, 30 to 50. So having said that, if you are in that range, 30 to 50, then these will probably already be pretty close to being set where they need to be, if not right on. Your incoming pressure is going to have some control over where these need to be set. So again, if you're operating within those parameters of 30 to 50, then these are probably pretty close. But what I want to walk you through is just a basic understanding of how this works, and then give you some practical ways to be able to adjust this. So when we talk about putting ozone into solution, there are two things that we're balancing. There's the concentration of ozone that's coming out, so that could be 5%, it could be 90%, whatever. There's the concentration of the ozone, and then there's the volume of the ozone. And these things are generally inverse to each other. So as the concentration goes up, the volume goes down. And the inverse is true, right? As the volume goes up, the concentration goes down. The more time that the gas spends inside the generator, the more concentrated it becomes. But if it's spending more time in the generator, that means that it's not flowing out as much, right? And that's why those numbers go opposite directions. And the opposite is true. If we have a whole bunch of ozone flowing out of here, there might be a lot by volume, but it's not very concentrated. And the reason I'm explaining that is because when we're talking about hitting your ORP set point, getting the ozone levels up to where they need to be, there's a balance between concentration and volume that has to exist. So if you were to plot these two things on an XY graph, concentration and volume, what you would see is that you would have that parabola curve, if you remember back to geometry, right? It would go up, and then there's going to be a sweet spot at the top of the curve where both those things are balanced relative to each other, and that's giving you your maximum production. And then if you continue to go too far the other way, then you'll fall off of that curve, the top of that curve. And so what we're trying to do is have you adjust these two things, concentration and volume, so that you're somewhere near the sweet spot at the top of that graph, the top of that curve. Now, you don't have to be OCD about this. In most applications, it's not going to be imperative that we get it exactly right. We just need to be somewhere towards the top of that curve. And so what I want to do here is just give you some practical things that you can do to achieve that. If you have a system that has a generator like this, it's one of these bigger ones. Basically, if it's not like this little small black one right here, we're going to have you adjust your oxygen concentrator here so that the flow is on about 3. And this is measured in liters per minute. You'll see the little ball here, it should be at about 3. And then what we're going to do is we're going to come over to the injector right here, and we're going to adjust our needle valve. With this on 3, we're going to choke this down until this comes back down to about 2.5. In most applications, around 40 psi, that's going to give you the balance that you need between these two. Now again, I said in most applications, you could be exactly 40 psi coming in, and there are other things, water quality is a big one, that could determine whether or not that needed to be exactly right. But what I'm saying is 85–90% of the time, if you adjust this to 3 and then choke this down to 2.5 by using the needle valve like we just talked about, that's going to get you where you need to be. Now, a couple quick considerations. The way that you're going to know that this is right is by watching your ORP. So if you have a 550 set point up here and you think you've got these balanced, what you're going to do is you're going to watch your water for a little bit. You're going to look at your set point. If you're having no trouble hitting your 550 set point, then these are at least balanced enough. Again, you may not be at the peak of that graph, but they're at least balanced enough to where you're able to put enough ozone in. But if you're watching your ORP here and you're not hitting set point, or if your system is having to run all the time just to barely maintain set point, that might be an indication that your concentrator and generator are not balanced appropriately. Now, it can be other things as well, and we're going to talk about that in the troubleshooting section, but it could be, one of the things it could be is that they're not balanced right. So what you can do is you can try adjusting this flow from 3 up to maybe 3.5 or so. You can try adjusting it a little bit higher and then still choking this down about 1/2, right? So if you have this at 3.5, choke it down to 3 with your needle valve. And then same thing, we're going to watch our ORP. If that corrects the problem, then that means you did okay, right? Now, what if it gets worse? Well, that means we should have went the other direction. So instead of starting at 3 here like we did initially, we're going to start at 2.5 and choke it back down here to 2. So again, all this is just a practical way of getting you to be able to adjust this concentration and volume without understanding all of the physics that go into it. So, as always, you can feel free to call us if you're messing around with this and you can't get it right, or if you mess it up and can't get it back in where it was. That's fine. You can always call us. But this is generally a pretty easy thing to do. Now, on this system, there's going to be one other consideration. If you have this black generator, This generator does not produce as much as ozone as the one that we just showed. And so you're going to adjust it in the exact same way, except the values that you're going to use are a little bit different. Instead of starting off here at 3 like we did on the system behind me, you're going to start off at 2. And then we're going to choke the needle valve to bring that down to about 1.5 right here. And then if you wanted to adjust it, it'd be the same way. If you feel like you need to adjust it, we can go up and down in the same manner. But you'll start off at 2 on this concentrator and 3 on this one with this type of generator. The final consideration here would be only if you have one of these black generators. So if you have the generator behind me, we've already covered everything that you need to know about that for now. This particular little generator though, it has an extra switch on the top. And when you look at it, it says high, off is in the middle, and then there's low on the other side. What we recommend is that you leave that switched on to high all the time. When that switch is on high, it's producing 100% of its capacity. When it's on low, it's producing 40-ish, maybe 50%, somewhere in that neighborhood. What I would do, again, is leave this on high all the time. But if you look at your ORP and you're having trouble hitting ORP, all right, that would be an indication that you either need to balance these things or one of the other things which we're going to cover in the troubleshooting. But again, if you're having trouble hitting the set point, if it's not getting up there as high as it should be, and this happens to be set on low, then don't change anything else about your system. Come up here and flip this on to high. It may just need, this may just need to be on the higher setting. But again, if you are leaving that on high all the time, you don't have to worry about it. So the opposite of that is true. If you look at your ORP and you're just way overshooting your set point, it could be that you need to flip this down to low, right? Because if you're overshooting your set point, it's not a problem with the balance between your concentrator and generator. You're not having any trouble putting ozone in the water. In fact, you're putting too much. So in that case, I would consider coming down here or coming up here and flipping this switch down to low. But if you have this system right here, it's either on or off. When it's on, it's making at 100%. It doesn't ramp up and down. So the same things happen over here, too high, probably not going to happen. But if you're too low, definitely could be an issue with the adjustment between the concentrator and generator. Last thing here, wrapping up ORP and this generator section, this little light right here, if you have a generator that's like this or similar to this, this light will be on when you have power. It'll be green when you have power, but it's not on. And it will flash orange, as you'll see here in just a second, when it's making ozone. If you have the little black generator over there, there are no lights in this fashion. But for this one, you'll see I've got it powered off here for just a second. When I flip the power on, you will see that orange light come on in just a second. So you'll see that light begins to flash orange, and you also notice that high-pitched squeal. That's how you know that this generator is producing ozone. So in this section, we're going to move into the maintenance and the servicing component of the system. We're going to go through all the things that you need to do to keep this system in good running order. First thing we're going to do is talk about the generator. As you see, I've already removed the cover here. In this particular type of generator, you'll see that there's this little desiccant filter on the inlet. So here's the line coming in, and then coming right through here, you'll see that they got this little filter here, and its job is to absorb any moisture that may come through from the concentrator. We want to maybe open this up, let's just say twice a year, and look at this right here. If these crystals are nice and blue or like a dark purplish, then they're fine. When they begin to absorb moisture, they start to turn a lighter color, and if they're totally used up, they turn like a really bright pink almost. And so the way that we remember that is blue is new. Open that up a couple times a year, look at it, make sure that it looks like this. If it is, you're good to go. If it's starting to lighten or turn pink, then you can let us know. You can unscrew this really easy, and we can send you a replacement. But doing this will prolong the life of the generator, because as we get moisture in here, you begin to produce nitric acid, which eventually will tear up the generator. Next item that you're going to need to service once in a while will be the oxygen concentrator. And there's really not that much to do on your part. I'm going to take a flathead screwdriver, come into the side here, and just pop this little opening in the back open. That comes off. And then you'll see that this just pulls right out of the back. About once a year, I would just replace this. If you don't, it's not going to be the end of the world, but it will prolong the life of your unit without having to do further servicing, which I'm going to talk to you about now. So about once a year, you'll see in the back there's a little plastic tube that it pops in. You just stick it right back in there. and pop this right back on. That's the part that you can do on your own. There are structures in here called sieve beds, and these are the structures that are actually concentrating the ambient air down to oxygen. They're essentially filters. Like any other filter, they're going to need to be cleaned and serviced periodically. Now, this is not something that you're going to be able to do yourself on site. What I recommend is you just send it to us. Let us service those for you, and then we'll send it back to you. Now, one thing to consider here, sometimes we have these parts in stock, sometimes we don't. If we have those in stock, typically we can service those beds and get them back to you in just less than a week. If we do not have those, then it could be much longer than that. So this brings up another point of consideration. If your water process, let me say this a different way. If our system is critical enough to your water process that you cannot be down and be without this for 2 or 3 weeks potentially, then what you may want to do is consider purchasing a spare oxygen concentrator so that when, not if, but when these sieve beds need to be serviced, you'll have a backup that you can drop in line and you can continue running. If our system is not quite that critical to your process and you can be without the ozone treatment for a couple weeks potentially, then that's fine. You may not need a backup. We just want to make you aware that it could be a few weeks without the system, and that way you can make a determination on whether or not you need a spare. Okay. Next up on the servicing list would be the ORP probe. We've already talked about how to calibrate that, how to adjust your set point, all those kind of things. So we'll just make mention of that here. We won't dive back into all that. One other quick thing about this, as you're calibrating this probe, and again, we recommend that you do that once a quarter. It could be a little more, could be a little less, depending on how clean your water is, but if you do it once a quarter, you should be mostly okay with that. So as you're calibrating this once a quarter, what you're going to start to notice is that you won't be able to calibrate up to 470. You'll also notice that the gap between what the probe is actually reading and then where it needs to be calibrated, you'll notice that that gap is getting larger and larger. So that's an indication that the probe is getting closer to the end of its lifespan. There will eventually come a point where no matter how much you turn that screw that we talked about there that we showed you, it won't calibrate up to 470. At that point, you're just going to discard this and you need a new probe. We have probes on other systems where we actually rebuild those and whatnot, but on this one, this is meant to be discarded. Next up is the ozone pump. Now, I will say that you very rarely will have to do anything with this. The only time you really would have to do anything with this is, one, if you've had this thing for like 10 years and you have to change out a seal or something unforeseen happens, or something that's normal wear and tear, or if you have really, really, really dirty water. So we have some applications where these things go and they have so much iron and manganese are the main things, but they'll build up on the inside of the pump. Now the pump will still run, but the way that you know that the pump needs to be clean is by looking at these pressure gauges. So normally there should be about a 40 PSI difference between these gauges when the system is running. If you're at 40 normally and then you've had this for a couple years and you see that these gauges are down to say like 30, that's a pretty good indication, especially if you have dirty water. That's a pretty good indication that we need to clean the pump. We have a separate video on our YouTube channel that will show you how to take this thing apart, how to replace the mechanical seals if you ever need to do that. But generally speaking, you're not going to mess with this thing unless you think that there is something wrong with it. And again, that's pretty infrequent. Next up on the service list is the injector. We recommend that you just do this when you calibrate the probe. So both of them about once a quarter or so. If you have really dirty water, you might need to clean it more than that, but generally once a quarter is going to get you about where you need to be. So the first thing we're going to do is close these valves so that when we take this off, we're not going to be shooting out a bunch of water potentially. I have already loosened this with an 11/16 wrench, but you're going to take this off right there, and then we're going to disconnect from the side port. Just take this whole assembly off, just like that. Now, when we clean this, the first thing you're going to want to do is take out the ball and spring. So there's a built-in check. Get my screwdriver out. And so we're going to take these pieces out. Now, just pay attention when you take these out. This is not complicated, but if you don't pay attention when you take them out, you may not know how to get them back out. So we're going to take out this little stopper first, and you're going to see that next comes out the ball as such. And then inside there, you can also see that there's a little spring, okay? And they need to go back in that order. You're going to take these pieces out. We're going to disconnect here and here, and then we're going to soak this injector in a mixture. We usually do about 50-50 muriatic acid and water. You don't have to use muriatic. You could use pretty much any acid that you have on hand there, but that's going to loosen any iron, manganese, anything else that may have built up in the injector here. Now, it's also important to notice you're going to need a little wire brush. The part of the injector that needs to be clean is not the part that goes this way. It's right here in the side port. Inside here, and you can't see this, but this side port makes a 90-degree turn and goes up in here, and the hole is really narrow. That's the part that gets dirty and needs to be cleaned. You can't really even get that brush in there fully where you need it, but that acid mixture is going to help loosen everything. And so then you're going to take that brush and just kind of go around in there. You know, in a perfect world, you'd be able to make that 90-degree turn, but again, you just do the best you can with it, and you're depending on the acid to loosen that up. When you're done, we're going to reinstall the spring. Then we're going to stick the ball in. And then lastly, we're going to put in that little stopper, and then we can reconnect our side port assembly and then our tubing. We've already covered this in the installation, but periodically you are going to need to change the bag in the filter. We already showed you how to install a new one, and you're going to do it the exact same way with the added steps. We're probably going to want to go ahead and put our system in bypass mode so that we don't have any water flowing through there. Next, we're going to want to use that drain in the back that we covered initially just to let off some of the pressure. And remember, we're going to need to drain that water level down low enough so that we can actually get the bag in there without spilling out a bunch of water. So again, we're going to bypass, we're going to depressurize the system and drain some water out, and then you're going to simply install the new bag the exact same way that we showed you at the beginning of the video. And also keep in mind, when we put the collar and the lid back on, and we're going to resume operation, we need to vent that filter the same way that we showed you at the beginning of the video to let that air out while it's filling back up with water. Last thing you need to know about this is how often do I need to change the bag. We have this pressure gauge here, which we talked about on the outlet of the filter, and then a little bit harder to see, but right here between the filter and the contact tank, we have a gauge on the inlet of the filter as well. What should normally happen is that you should leave that bag in there until you get about a 5 psi sustained differential between those gauges. So for example, if the pressure going into the filter is 40 and this one here is about 38, that's fine. It's normal to get about a 1 to 2 psi drop across that filter. But when this is 40 and then your outlet is getting closer to 35, that's about the time you know that it's time to change. So again, your pressure can fluctuate just a little bit, but when you have a sustained drop of about 5 psi, that's the indication that it's time to change the bag. From time to time, your flow switch is going to need to be serviced and cleaned as well. To do this, it's very simple. I've already taken out the screws, but similar to some of these other things, you just want to make sure that the system is bypassed, because if not, you're going to take this off, it's going to spray water everywhere. But bypass your system. Maybe use one of these drains down here to depressurize the system just a little bit. And then there'll be 4 screws, 2 in the front, and then 2 right here, that you'll take out. These 2 on the side you don't need to mess with. That gets you into the electrical stuff. But you'll just remove these screws. You'll take this off. We've made this with unions so that you can take this out if you need to. Generally, you probably don't need to, but then you can let this hang here. If you look inside here, there's a single piece. It's magnetic. And that's it. It fits down inside this little housing. So what can happen from time to time if you don't clean this is that your system can get stuck in the on position. So remember, we talked about how the system is supposed to recirculate for about 5 minutes after water stops flowing. The flow switch is what's telling it that water has stopped flowing. If you get iron and manganese buildup in particular in here, it messes up this magnetic function. So your contact will stay closed and the system will stay on even though you're not using water, and it's longer than that 5 minutes. So again, if your system is continuing to run past that 5 minutes, that 5-minute timer, and you know for sure that you don't have any water flowing, there's one of 2 possibilities. You either have a leak somewhere, that's always a possibility, and that water actually is flowing, or it might just be that your flow switch needs to be cleaned. And so again, you're going to undo this, pull this out, and we're going to clean it in the same way that we talked about with the injector. Make up a little mixture of muriatic acid and water, 50-50. Soak that just a little bit. You might even, if you can clean the water out of this, you might even pour just a little bit in here. Take a little wire brush, scrub it out, scrub this. But once you're done with that, all you're going to do is drop it back in there, put the housing back on, make sure this little O-ring is seated here, put your screws back in, and you're ready to go. Again, we have this light on the control panel as well. If you think your system is running too much, one thing you can know for sure, right, you can look at this green light And if it's lit up, it's telling you that your flow sensor is on. That tells you for sure my flow sensor is active, and then you can be fairly sure it's coming from there. The last item up on the servicing and maintenance list here is a really important one. It's going to be the servicing of the check valves. Now, we mentioned already that there's a built-in check valve on this black injector. It comes with it. It's not a very good one, so we're not really even relying on that, even though it does work most of the time. We have installed our own little plastic check valve here between the needle valve and this coupler. And we also have a second one up here in line between this valve and these fittings. So what I want to do real quick is talk to you about how this works and then how often you need to change this stuff and how you do it. And the purpose of this check valve, both these check valves, it's to not allow water to back up into the generator. If these check valves were to fail, water could move up this tube, through this, and then through this, back up into the generator, and that would ruin your generator. So we want to make sure that doesn't happen. And as long as you follow the steps we're getting ready to outline, everything will be fine. These check valves need to be changed periodically, just like some of the other things that we've talked about, and they're made to be discarded. They're really cheap. We keep these on hand. We can mail you a handful of them if you ever need them, so you can keep them on hand. What we recommend is that you change these at least once a quarter. I would say once a quarter is going to be fine for most people. With that said, if you should ever see water in these tubes, then it's definitely time to change them. So let's just say maybe one right out of the box was bad for something, just kind of a fluke thing. You need to go ahead and change it. You're not waiting for the 3-month mark. So it's every 3 months or when you see water in this, whichever comes first. So again, this is very important. Again, the way we're going to do the changing out is we're going to disconnect that tube just like we did when we cleaned the injector. We can take this side port off, and then from there you can do it any number of ways, but you're just going to unscrew this. These are 1/4-inch threads, and then you're going to put the new one in there. It's very important to realize that these have a directional flow. If they didn't, they wouldn't be a check valve. So we want to make sure the arrow is pointing this way towards the injector. If you put this in backwards, it will actually suck water out. It'll do the opposite of what it's supposed to do. So that arrow must be pointing towards the injector. That's for this one. For this guy up here, it's going to be the same thing. This whole apparatus, you can see, is clamped down. So you can undo these clamps and kind of take this out partially. That'll make it easier to work with, just however you want to do it. It's fairly intuitive. But same thing, you're probably going to undo the hose here, 11/16 wrench, and then from there you can begin to unscrew these fittings to get this check valve out. Same thing as the check valve we just talked about. The arrow on this needs to be pointing towards the injector, which is going to be that direction. Last thing I want to talk to you about here is how this little valve is supposed to work. When the system shuts off, the concentrator is still going to be pressurized. And it's not good for the cells inside the concentrator to sit there and be pressurized. So when the system turns off, you're going to hear this little valve open, and then through this fitting here, it's going to allow that air to escape from the concentrator. So the system is going to depressurize so that it's not just holding that air. That means when you turn your system on, your concentrator and generator are not going to get up to where they need to be. It's going to take a few seconds because they've depressurized. So when it turns on, if you see a red light on your concentrator for a few seconds, that's fine. Same thing, if your generator doesn't turn on right away, that's fine because it has to get pressurized before it turns on. So again, this valve should be closed normally when the system is running, and it should be open when the system is off, open to allow these things to depressurize. This valve is helping to protect your generator. If water gets past this first check valve, this thing will be stopped by the second check valve, so we have a fail-safe. And then when the system is off, if water should back up, this valve would be open to let water out. So remember, we talked about at the beginning too, you may want to hook this up to a drain. But that's how this whole assembly works. So again, it's very important. If you get water in your generator and you haven't changed these check valves out, that's going to be an expensive fix. We're not going to warranty that. You must change these check valves out at least once a quarter. And again, we keep those on hand. They're cheap. We can get them to you really fast. In this section, I want to go over just a couple common problems that we see, things that we get phone calls about, and this might give you a quicker answer to troubleshoot some of these things. And of course, if this doesn't get you the information you need, you can always call us and we'll help walk you through this. But again, this is a common thing that we get. Probably the #1 most common call we get as far as something's gone wrong is customers will say, I'm not able to hit set point. I've got my set point at 500, I'm reading 300. And we've already alluded to a couple of these things, but I just want to run through a few of these things real quick to help you out here. So if you call us and you say, hey, my system's not hitting set point, what's wrong? It could be a number of things, and this is exactly the list that we would go down. Maybe not in this same order, but these would be the things that we would hit. First thing we would ask is, what's the pressure differential on these two gauges? Like we talked about, if you are normally supposed to be about 40 psi and you're now at 30, you're not getting as much boost across that injector. That's a pretty good indication that your pump probably needs to be cleaned and serviced. That's one of the things that could be keeping you from getting enough ozone into solution, which would give you a low reading, not able to hit set point. Another thing that could be, it could be simply that your probe needs to be calibrated. If it's been a long time since you calibrated your probe, it's entirely possible that the actual ozone content of your water is just fine, but your probe is reading wrong. So that would be another thing we would ask you, when's the last time you calibrated your probe? So we would check on that. A third thing we would check on is, when's the last time you cleaned your injector? If you get a buildup inside the injector on that side port, that impacts the amount of ozone. Everything else may be functioning properly, but the ozone simply can't physically get into the water. A fourth thing that could be keeping you from hitting set point could be, is my concentrator and generator out of balance? Now, ideally, if nothing changes and you get those things dialed in, you should really never need to mess with them unless something else changes. Maybe your incoming pressure changes somehow. Particularly that can happen if you have municipal water. We see situations where people sometimes just start turning knobs and whatnot, right? So again, as long as nothing else changes, once you get these dialed in, it should be right. But again, that would be another thing. Hey, let's work through this. Do we need to adjust your concentrator and generator? Another possibility is that your concentrator could simply need to be serviced. If you're not starting off with enough purity, if you're not starting with 95% oxygen, you're starting with 50% oxygen because this is needing to be serviced, that's going to impact your ability to get ozone into solution, and it's going to give you a low reading and not where you cannot get up to set point. So I would say, when's the last time you had your concentrator serviced? We might also ask you, do you have any other lights on besides the green light on the concentrator? There's red and yellow lights that can indicate something's wrong or something needs to be serviced, so we'd ask you about that. It's a possibility that you also could have something directly wrong with the generator itself. Not the only thing, but remember we showed you this little filter in here once in a while. If you are starting to produce nitric acid because that filter is shot and you've got moisture in your generator, that can affect your ability to get up to set point as well. So we might ask you some questions about your generator. Finally, again, I've already alluded to this, but has anything else changed? You know, occasionally we'll see a situation where the system is designed to run for this water source, and then for whatever reason the customer changes water sources. That new water source has a much higher demand for ozone. It requires more ozone to treat that water. If something like that happens, that may impact your ability to be able to hit set point. So there's any number of things outside of our system that are not within ATT's control but would still impact our ozone production. So it could be any number of things like that. So if you run through the pump, the ORP probe, the injector, the concentrator, the generator, all these things that we talked about, if you run through all those things and none of those things are panning out, it's a pretty decent chance that there's something else that is impacting the production. But again, at that point, you're going to be on the phone with us and we'll help you walk through that. The last problem I want to cover as far as troubleshooting, I've already mentioned, is the system not turning off when it's supposed to. So like we already talked about, it's normal for the system to run about 5 or 6 minutes because of that timer. You stop using water, system runs for a few more minutes to make sure that all of the incoming water is going to be fully treated and ready to use when you do turn on the system again. But again, if this flow switch needs to be cleaned, the system's not going to turn off. 10 minutes, 15, 20 minutes is going to go by. You haven't used water and this thing is still running and you still have this green light on. Almost the only thing that can even be is that there's something wrong with that flow switch, and 99.9% of the time that's that it needs to be cleaned out. There are some other little things that you could possibly run into with the system, but those are the two big things that by far we get calls about. If you understand those things, that'll enable you to work through those things on your own and probably not even have to give us a call. If there's anything else outside of that you need help with, just give us a call. All right, in this last section, I told you we were going to go over this backwashing filter. You know everything you need to know about the bag filter system that we covered previously. So if you have one of those, you don't need this section. But again, for you guys that do have this backwashing filter, this would be everything you need to know about this filter. Everything else we said about the system will apply to this particular system. And then we're going to add the instructions about this filter to that as well. So the system is going to arrive just like this. When you unpack it, it'll arrive just like this. This filter will be sitting here. The valve will not be installed. We will have this pipe already installed in the middle. It'll look exactly like this. So the first thing that you're going to do is install the valve, and then there's just a little bit of associated plumbing. And I'm going to show you how to do that right now. So the first thing you're going to need to do is install the valve. Now I'm not going to show you how to do that just yet. I'd like to explain something first. The reason that we have you install the valve first is because this tank here may turn a little bit during shipping. And what's going to happen is I'm going to show you how to put this media in here. And after you put the media in, this is going to be very, very heavy, and it's going to be hard or maybe even impossible for you to rotate this filter. So what we want you to do is put the valve on, twist it, tighten it as much as you're going to possibly tighten it, and make sure that it's facing forward, that all the plumbing lines up, all that stuff. In other words, make sure that this is sitting exactly where you want it to sit. Because again, if this moves and then you put your media in there and then you tighten up your valve and your valve is not straight, this might not even be able to be moved. At best, it's going to be very difficult. So for the sake of not doing this twice in the video, I'm just saying you're going to install the valve, which I'm actually going to show you here in just a minute. So let's pretend that you've put your valve on and you've got your filter where you need it, and then you're going to untwist it, and we're going to begin by putting media in the filter. So the first thing you're going to do is cover this tube. We do not want to get media in this tube. The media needs to fall around the tube. To do that, we have included with your system a funnel. It might be blue or it might be a black one just like this. But we're going to put that tube right in the middle of it, and we're going to cover that tube either with tape. Sometimes a paper cup works really good. However you do it, a rag that you stuff down in there, however you do it, you need to make sure media does not go down in there. And then we're going to use this funnel to help you pour media in there. You're going to have a couple bags of gravel. Will look something like this. You cut a hole in it, pour it in there. We'll send you the appropriate amount of gravel. One final thing about this media installation, I would pour one bag and then I would recheck the center tube to make sure that it's centered. If it's not centered and you continue to pour media in there, you're going to get to the top and the tube is going to be off to one side, and you may or may not be able to get the valve on, and at best it may be hard. So pour one bag and then recheck, move the tube around a little bit, make sure it's centered, pour another bag, take the funnel off again, make sure the tube is centered. After you get 3 or 4 bags in there, it should be fine, but again, I would just double check, because if you get all the way to the top and it's not centered, then you've got a mess. After your gravel is complete, you'll pour in a layer of glass. Same thing, we'll send you the appropriate number of bags of glass. It looks like this. You're gonna cut it, pour it in. One thing about the glass, you will probably actually have just a tiny bit more glass than you need. If we send you 5 bags of glass, what I would recommend is put 4 in, and then you're going to measure. This is a 65-inch filter, and we want it to be 40% empty. So when you install your glass, you should have 40% of this distance. So just for the math, if this was 100 inches tall, we would want to measure 40 inches from the top to the glass layer in the bottom. I would stop 1 bag shy and just kind of double check and make sure that, you know, we could have made a mistake on our part. We might have somebody new that put an extra bag in, whatever. But again, you want to make sure that this is 40% empty. So if you measure it and you're still not quite 40%, go ahead and add some more of that next one. It's not imperative that you get it just perfect. So if you're supposed to be at 28 inches here and you're at 27, that's fine. Or if you're at 29, that's fine. You know, an inch or maybe 2, either way is fine, but just try to hit it as close as you can, 40% empty. Now, after you have installed your media, we're obviously going to take the filter off, make sure that we take off this cup or remove this tape, whatever it is, and then we're going to be ready to reinstall the filter valve. And I'm going to show you how to do that. Figure out how to get this. All right, so here we've got the filter valve. This will be shipped separately in a box. It might be strapped to the top of the system here whenever you get it originally, but it'll be with the system. You're going to take it out of the box. It's already got some plumbing that's on there. Just leave that. Take some pipe lube here. I've got some here. And we're going to lube that. And then we're also going to put some on this tube here, this center tube that we had covered up so it wouldn't get media in it. And just make sure that that's nice and slippery. And then what we're going to do is make sure that the valve sits right down on top of the tube. The lube should help. Don't force it. You can wiggle it back and forth a little bit if you need to. Now, one important thing about this, and this is very, very important, if you are not 1,000% sure that this valve is on here and not cross-threaded, then do not tighten it. It tightens to the right, just like any other screw, righty-tighty, lefty-loosey. The way we recommend you putting this on, though, is to back it up. So actually loosen it until you feel it drop down in the threads right there. You can see it, you can hear it, you can feel it if you've done this a few times. Even then, you're only going to tighten it maybe a half rotation, 1 rotation at the most, and then we are going to wiggle. If you can feel that move in the thread, but it does not come out of the thread, then you're probably okay. Then we're going to turn a little bit more, maybe a half turn. We're going to check it again. It still wiggles, but doesn't come out. We're going to go another half turn, okay? And then about 2-3 rotations in, it's going to stop wiggling, but it's also going to be turning smoothly. So one, if it's not wiggling during that first rotation or two, it's probably cross-threaded. And also, if it's not turning smoothly, it's definitely cross-threaded. The reason we're making such a big deal about this is if you cross-thread this valve, it will ruin this vessel, and we cannot fix it. It cannot be fixed. And if you think about it, then you're really going to have a mess, because you're going to have this filter, which is inside this frame. It's going to have all this heavy rocks and glass in it. There's not going to be any way for you to get it out, at least no good way. And so again, we just need to make really sure that we don't cross thread this valve. If you go through those steps, it'll be fine. But if you get this thing on here and it's leaking, it means you cross threaded it, and we cannot warranty that. Take your time. If you're skittish about it and you even want to talk to us about it, that's fine. If you call me, I'm going to walk you through the same steps I just gave you. But please make double sure that you're not cross-threading this valve. When you're sure that it's okay, go ahead and finish tightening it on. Depending on the layout here, this cover may or may not hit this little pipe here, so you might just want to open that up to make it a little easier. Everything is very tight, but we want to make sure that we get this on here nice and snug. Hopefully you did the first installation right and you've got this lined up. You might be able to wiggle this just a little bit, but by this point it's going to be very heavy. Hand tight is probably okay, but it needs to be very hand tight. If you'd like to get a large set of channel locks, you can put it on the body of the valve here. But again, you need to tighten it that way the first time to make sure that this is all spun the right way. So if you hand tighten it the first time, hand tighten it the second time. Make sure you do it right, or the same way both times. So after we've got this valve tight, there's a couple other little pieces of plumbing that are going to need to be installed, and then you're going to be ready to go. They look pretty similar. They go over here on this inlet and outlet of the filter. All you're going to do is tighten this, and then tighten your other side over here, the union. Okay? And then same thing here. These pieces look similar, but they're not interchangeable, and you'll figure that out. And then we tighten our last union. The plumbing installation is complete at this point, except for the backwash out. So we mentioned already, this is an auto backwashing filter. Unlike the bag filter that we saw on the other system, this one will clean itself if it's set up that way. We are going to need to bring power to the filter. This is the component, as I mentioned earlier, it's not powered from the control panel. I'm going to show you how to hook up the power here. But for it to backwash, this needs to be plugged in. This does not have to be plugged in for it to filter, because the filter is purely mechanical. If you don't have the backwash hooked up, it's just not going to do it automatically, and you'll have to do it manually, which I'm going to show you how to do, but really there's no reason to do that. You want to go ahead and have this hooked up to power so that this will clean itself and you won't ever have to worry about it. So with that, the only other additional piece of plumbing is this backwash out. We're just going to leave you a male adapter right here. Keep this at 1.5 inch size, please, and this needs to go to a drain somewhere. Please keep in mind that when you plumb this out, there's going to be a significant amount of water and pressure coming out of this. If you're plumbing this into like a floor drain, for example, we don't want that thing to go straight down into the floor. You want to kind of 90 it so that it goes with the drain, because if you angle it straight down perpendicular to the floor, you're going to splash water out of that drain everywhere because of the flow rate coming out of here. So just some common sense considerations when you're plumbing this out. Just know, again, relatively high flow rate, decent amount of pressure. Just take that in consideration when you're plumbing this to the drain. So next, we're going to show you how to bring power to the filter. This is the converter. It will already be mounted on the skid, probably right here. And you'll see this side, you're just going to plug that into a regular 120 outlet. And then this side will already come pre-done. And you can route this wire however you want to. But what we're going to do is we're going to come in the back, the upper left corner here. This piece will come out. But we're going to feed the wire through this hole. And then we're going to put the restraint around it. Put it in the right way. It's taking me a second. There we go. We're going to put the restraint around it. Just leave 6, 7, 8 inches of wire sticking out here. And then we're going to push that into the hole. May need to use a pair of pliers here, squeeze it, and push it in. There we go. That's going to hold that from moving. You can also do that step last after you make the connections if you feel like that's easier. But there's going to be a little end piece hanging here ready for you. You're going to take the piece you just put into the filter, snap those together. You'll hear it click. If it doesn't, make sure and push that little arm down. They shouldn't be able to pull apart. Just kind of give it a little test like that. Second part is you're going to connect your ground screw right here. Very simple. Take your ground wire, put the screw through there, and screw it back in. One thing I want you to notice, if you leave a little bit too much wire coming through here like I did, we really don't want to leave this hanging off, because when this is moving, this piston is moving, technically I guess some of this could get caught. If you need to, take the restraint out, and we're going to do that the same way that we put it in, except in reverse. We're going to grab it from the back. You're going to squeeze this direction from right to left and then push it through at the same time. And then we can shorten up that wire a little bit. So again, that might be handled by just putting your restraint in last. We want to make sure that this is not flopping around. We kind of want this up here nice and tight away from these moving parts. Next, we're going to cover the operation instructions for this filter valve. So you can see I have unscrewed the little screw. I have flipped it open to expose the controls. So here we have the timer assembly. In the middle, we have this piston here that's going to move in and out. I'm going to show you. And then we have the motor here on the left. A few things here. First, one of the things we want to do, remember we said that you can backwash this manually or in auto mode. We recommend that you leave it plugged in and let this thing backwash in auto mode. And you're going to do that on the same frequency that we talked about for the bag filter. When you have a 5 PSI differential across the filter, the inlet versus the outlet, and we've got the gauges down here to the right of the filter, just like we do the bag filter. So once it is time to backwash, you're going to make sure that these controls are in place. We're going to set the time of day. So you can see we're going to line the time of day up with this little white tag that says time of day. We're just going to push in this red button, and we can spin this wheel. There's 6 p.m., right? There's 11 a.m., there's 6 a.m. Whatever your current time of day is when you're plugging this in, that's when you want to set. Also keep in mind that if you lose power and you need to backwash at a certain time of day, you might need to come back and reset this time of day if it's off for a couple hours, for example. Next, you're going to set the frequency of backwashing. So am I going to backwash every day or every other day or once a week or whatever? And we're going to do that by this. Now, if you need some help determining that with your process, that's fine. We can do that as well. But remember, again, generally, you're going to backwash when you have a 5 PSI differential or once a week, whichever comes first. So if you don't have a 5 PSI differential every week, I would go ahead and backwash this at least just once a week. It's good for the filter. But if you need to backwash every other day, for example, we're going to adjust these little pins here. They move in towards the middle or out away from the middle. When they are pushed in, that represents a day that they will not backwash on. If we pull these away from the center, that represents the day that they will backwash on. So if I need every other day, there's 1, 3, 5, 7, 9, 11. So I can do that. I can set this for every day. I can set this for once a week. And I'll do it all the exact same thing. So each one of these numbers represents a day. Pull the pin away from the middle to backwash on that day. Next part of the controls, we're just going to pull this open. You'll see this swings out to the right, and it exposes this pin assembly. Now these pins are going to determine the way that your system backwashes. Now we will have these preset for you. There are probably, with relatively few exceptions, you should really never have to mess with these pins unless we tell you to for some reason. But again, this will come set. But these pins just pull out with a needle nose plier. You push them in, they wedge in there, should you ever need to do that. There are several different phases to backwash, and I want to show you what that looks like. Now this pin has 3 groups of pins with spaces in the middle. Typically yours is going to be 2 groups of pins with 1 space in the middle. Typically there'll be 4 pins, a space of 2 pins, and then 3 more pins. That will give you 3 total phases of backwash. But this one, just since we're learning here, would have 5. You'd have 1, 2 for the space, 3 for the pins, 4 for the space, 5. So every time that these pins turn on this wheel and we trip this little arm here, something is going to happen as far as the position of the piston. The piston is going to control the inlet and outlet flows of the water so that the system cleans itself. You don't really have to understand all the particulars, just what I'm telling you here. So if you have this timer plugged in, you have your time of day set, all this stuff is working right, this wheel is going to be slowly spinning on its own anyway. You won't have to do anything with it. But just to simulate and show you what happens, when the system does go into backwash, you'll see the piston move when we turn it and the first set of pins trips this little arm. So you'll see that the piston stops when it gets to where it needs to be. And by the way, each one of these pins represents 2 minutes. A 4-pin, 2-space, and then 3-pin would be an 18-minute cycle. There's a total of 9 pins and spaces combined, so that would be an 18-minute cycle. Because every 2 minutes, another pin will rotate and trip this little arm until eventually we get to the next phase of backwash, and you'll see the piston move again. Okay, same thing, 2 minutes per space here, so 4 minutes. We'll get to the next space, same thing, or the next group of pins and the same thing. The piston will move, and you see how it works. Every time we get to a new phase, that piston is going to move until we finish. If this timer is plugged in and all this is doing it on its own, you don't have to do any of this. You don't even have to know any of this. If for some reason you are initiating backwash manually, you would do it the way I showed you. You would still have to plug this in. You would rotate the arm to the first pin, and then you would leave it. You cannot continue to rotate this through and get an effective backwash cycle. All you would do is plug it in, start it on the first pin, and then let it go. Once it reaches the end here, eventually it will reach what we call the home position. And you'll see this little notch in the wheel right there will trip this other arm that's behind there, and it'll fit right in there. That's the home position. So if we're ever troubleshooting something on the phone and we say the home position, that's what we're talking about right there. But again, if you leave this plugged in and you have all these controls set up, then you're not going to have to do anything. The only thing maintenance-wise that you really ever need to do with this filter is if you don't backwash it enough, the media can become congested. And then there's a manual clean-out process. So if you backwash this thing and you still have a really big pressure differential, more than 5 across there, that might be an indication that the media is too dirty and we might need to do an acid cleaning, which we can walk you through that. But for the biggest part, if you backwash this thing the way it's supposed to be done and you do what we showed you here, this thing for the biggest part will sit here and it'll run for years and years and years and years, and you never really have to do anything with it. Really about the only thing that can happen with this thing is occasionally the mechanism on the inside where that piston we saw that's moving in and out, it's moving down through a series of seals and spacers. Occasionally one of those seals can roll and go bad and need to be replaced. If that happens, what you're going to need to do is take this valve off and just send us the valve. So you would take it off in reverse of the way that we talked about putting it in. You would undo this plumbing, shut everything off, undo the plumbing, untwist it, and mail us the valve. That's pretty rare, but it does happen occasionally. Should that happen, what we've also done, and this part of the plumbing is a little bit different than the other system we saw. Unlike the bag filter, which does not have a bypass around the bag filter itself, you have to bypass the whole system if you need to do something with that filter. This filter does have an individual bypass, so you would close these, open this one, and water will come up to the filter, but it can't go. It'll go this way and then right back out your outlet. So this filter does have a bypass around it should you need to do some kind of servicing like that. But generally speaking, the filters just run for a pretty long time. We generally don't have any trouble. The only thing that we recommend that you do with any kind of regularity is maybe every 2 or 3 years, depressurize it, take off the valve, and just like we talked about measuring that 40% empty space in the vessel when you're filling it up, check the height of the media. See if we're still around 40%. What can happen over time is some of that media, depending on different conditions, it can backwash out a little bit, but generally it sits right there and you don't have any problem with it. But we recommend every 2 or 3 years you check on it just to make sure you don't need to add a tiny bit of media. But again, that's pretty rare. Now at the beginning of this video, I mentioned that we build these in 3 different options. We build it with a bag filter, with a backwashing filter, which we just covered. The third option, which is not represented here, would be with a carbon filter. You would probably use this in a system that maybe is being fed with RO water. If it's being RO filtered, there's really nothing in the system for us to filter out with one of these two. And so what we might do is use a carbon filter. Carbon converts ozone. So there might be some applications where we don't want to send a bunch of ozone downstream of the system. So you may just have a simple carbon filter instead of one of these other two that we've covered. If you do, there's really not a whole lot to say about these things. It'll be mounted where the other filters are back here. When you need to change them out, you'll just untwist it. Obviously, you would untwist the bottom. I'm doing the top because it's easier right here. You would first want to depressurize it by pushing that little button, and then you would untwist this. You'll take the old cartridges out, and you'll get your new ones. You'll pull these apart. There's a little plastic connector that goes in there. You'll use that same connector to put your new ones back together. Same thing as the valve installation. If you need to use a little pipe lube, that's helpful. But you'll stick them back together. drop them back down in the cartridge. You'll see in the very bottom there, there's a little fitting that fits in the bottom of that filter. It's made to kind of center it right there. You'll center that. Same thing, you've got a tube fitting that goes in the middle. That can be a little tricky to get on sometimes, but we're going to try to make sure that's centered. We're going to twist this back on, and then it'll be ready to go. Now, typically there'll be a plumbing manifold. You'll have a valve here, you'll have a valve here, and there'll probably be a bypass over the top so that just like the other filter, you could shut this off to work on it, but water can still flow through the system around the bypass.